me just cut your head off.
That's okay. Okay. Okay, so vectors have both magnitude and direction. So directions, as I mentioned, can be either positive or negative. Scalars only have magnitude. So when we talk about uniform motion, this refers to, write this down, constant speed and velocity. So that they're staying in uniform, they're staying the same. Okay? The same thing. Uniform meaning constant. So, displacement, a change in the distance and direction away from our reference point of an object, or we can say the origin, okay, where we're starting from. The standard international units are meters. It is a vector quantity, meaning magnitude and direction. So, distance versus displacement. Distance, scalar. So say I went and I walked 2 meters. Okay, I walked 2 meters. And then I turned around and walked 1 meter. My distance traveled is what? 3 meters. Displacement, however, is a vector quantity. So if I did the same thing, I went 2 meters, I turned around and I went 1 meter. This is where I started, this is where I ended. So what I do is I look from where I started and from where I ended and say, well, my distance, so it's a D with an arrow over the top, means displacement. Okay, so that's the key thing here, displacement. There's an arrow over the D because you're saying, well, this indicates direction too, or it's a half arrow. Okay, so what's my displacement? 1 meter. I need to give direction, so in reference to where I started, I've gone 1 meter right. Or you could say east.
Why would it be right if you turned around?
But from where I started to where I ended is only what I look at. Yeah. So even though you turned around and started going another way, you only look at from where you started to where you ended. Why can't I find it? Are you guys laughing at me? Or did something kind of funny happen? I keep seeing you guys giggling like you're trying to hold it in. What did Evan do? I want to know. What's funny?
Come sit behind him.
His hair? Yeah, I know. I think that I liked the Mohawks last year. A lot better than. Yeah, that's a good point.
Like they're wearing a hat and then it looks like nothing's wrong.
Okay, well, we should show what we're talking about here.
Why are you taking a video?
There's Evan. Okay. Oh, there's Lewis. Okay. Where's my other Friar Tuck? Oh, Lane. That's special. Okay. Great. Yeah, so we're just having a hard time focusing because this is what we have to deal with today. Okay. that good? Okay. All right. Velocity. Rate of change in an object's position. Rate means over time. So velocity is a change in an object's position over time. SI units are meters per second. So our vector quantity is a v with a what over it? An arrow. Okay? Equals change in d, delta, so the triangle means delta, which is change, divided by delta t. And actually I should put my arrow over my d as well. Because when I have a vector quantity as velocity, I need a vector quantity for displacement. Or you could simplify it and just go v with the arrow equals d arrow over t. Okay? Assuming you know it changes over time. Imagining things. Okay, again, delta means change. Speed is similar to velocity, it's just the scalar version. So, for speed is distance over time, not displacement. And we represent it as just a v is equal to d over t. So notice the differences. There's no arrow over the v, there's no arrow over the d. Here, there is an arrow over the v, there is an arrow over the d. It's important, I know it might seem like a very small detail, but it helps to keep your work consistent.
Is there like delta on those ones on the bottom?
Yeah, we could say that it's delta. I'll make you happy, I'll do this. Why? There we go. And you could simplify it and just not have the delta in it. Okay. So let's do an example. An object travels at a uniform velocity. So when you first start doing these questions, what is this? Vector or scalar? Vector. Okay. All right. That was bad. Okay, so that's a vector. And it's uniform velocity, so the same constant velocity. At 25 meters per second, west. What is the displacement after 10 minutes? So my v with an arrow is equal to 25.0 meters per second west. This is what I know about the question. I'm trying to find my d with the arrow over top of it equals question mark. My t is equal to 10 minutes. Okay, I have a problem. Can I use this t and this v together? No, why not?
This one's minutes and one's seconds.
Great, so I need to do my conversion. So, multiply, I have my minutes on the bottom, seconds on the top. How many seconds in 1 minute? 60 seconds in 1 minute. So I know that my t is 600 seconds. So now we can go, and these problems, this is a basic one from Science 10. So v equals distance over time, okay? If I rearrange this, if I want to get d all by itself, I need to get rid of t. So multiply by t, multiply by t. So now I have that d equals v times t. So d is equal to 25 meters per second west times by 600 seconds. D is equal to 15,000 meters. Specifically, then sig digs, how many sig digs do I have? 3. So I need to go 1.50 times 10 to the power of 4 meters west. You could just put a big W and put that in square brackets is generally what is common, is to put the direction in square brackets, or you could write the word west and that would be fine too.
In the diploma, you put 15.0 times 10 to the 3. Would that be right or incorrect?
15, oh, incorrect, yes, because scientific notation is like a digit with a decimal and then whatever other digits multiplied by 10 to whatever digit. So it's only ever one digit in front of the decimal place. So you do most definitely need to just go 1.5, yeah. One digit in front of the decimal place. Yeah, good question. Sometimes it is useful also to calculate the average speed or velocity. So average speed or velocity, okay, so my average speed is V equals D total divided by T total. So this is my average speed. My average velocity, you write your V with an arrow and then put AVG beside it, equals D with your arrow over top, total, divided by T, total. And this one we should actually put our V without the arrow and put AVG beside it too, for average. Okay, so a runner goes for a run and ends up going 5.72 meters north and 2 meters south over a time interval of 3.75 seconds. Calculate the runner's average speed. Okay, I'm just going to make a note to myself. This is scalar. Then average velocity is my vector quantity. So as I just put up before, my V without the arrow over top, average, is equal to D total divided by T total. Okay, so I'm going to add up all the distance they went, 5.72 meters plus 2 meters, divided by all of the total time, 3.75 seconds. This is equal to 2.0586 repeating meters per second. How many sig digs do I have? I have 3 sig digs. So I need to go 2.06 meters per second is my V without the arrow average. B is V arrow average, so now I'm finding my average velocity is equal to D with an arrow because now I'm dealing with displacement. Total divided by T total. Now, this is equal to 5.72 meters plus, because I need to add up all of my displacements. So, if I was to look and go by kind of the sign conventions that we did before, is this a positive direction or a negative direction? Positive. Okay? And then 2 meters south is a positive or a negative direction? Negative. So, when I'm determining displacement, it's in a different spot every time, I swear. Whatever. I need somebody to be my scorer. Okay. So this is my north direction. So it stays as a positive. It's north. Then I add my negative direction of 2 meters south. I don't need to write south in because I exchanged the south with a negative symbol. I said south is a negative direction, so I put a negative sign. Divided by 3.75 seconds. This is equal to positive 0.992 meters per second. So my V average, now I could write this as positive 0.992 meters per second and leave that as my answer. But since I started with north, south, east, west directions, that's how I'm going to write my answer. Okay, so what should my answer be for a direction? What direction am I going? Pardon? North. Because I have a positive here, so I'm going north. Now some of you, I can see this is probably an easy lesson for you, and that's okay, but it is important that we all get this stuff so that as we keep going, it's going to get a little bit more complex, so just bear with me. So in a high-speed chase car, the felon is driving at 12 meters per second east for 7 minutes. He pulls on his emergency brake and does a complete 180. He then proceeds to travel at 18 meters per second west for 15 minutes before arriving at his destination. It's going very slow. Okay, so calculate the average speed, or not very slow because it's meters per second. Calculate average speed. So this is my scalar. And this is my vector. So when I look at a question like this, there's two things going on. So I'm going to kind of highlight that to myself. I'm going to say, well, here, this is his first direction, number 1. That's kind of the first direction he was going, the first speed, etc. And this is the second. So I put like a number 2, or give yourself some indication that that's number 2. Okay, so I'm going to do A first, calculating the average speed. But I need to do 2 things separately. So let's just write out what our overall goal is here. V average equals D total over T total. Now, in my question, I have not been given my distance. So I need to find distance traveled. In order to complete this. So for my number 1 situation, my V is equal to 12 meters per second. So I'm just gonna say that's V1. T1 equals 7 minutes. That doesn't work, so I know I need to change that into seconds. So my T1 is really 420 seconds. Okay, so then to find my distance, I know my D1 is equal to V1 times by T1. So D1 is equal to 12 meters per second times by 420 seconds. So I know my D1 is 5,040 meters. So that's just for the first direction that he was going. That's just my first scenario. Now I'm going to do the second one as well. Too fast? Are we doing okay? So my V2 is equal to 18 meters per second. My T2 is equal to 15 minutes. So that's multiplied by 60 seconds over 1 minute, equal to 900 seconds. D2 then is 18 meters per second times by 900 seconds. So D2 equals 16200 meters. So now I can determine my average speed because I have both distances now. Okay? So now, therefore, that's what my little triangle of dots means. Therefore, now I can find my V average is equal to 5040 meters plus 16200 meters. Okay. Divided by 420 seconds plus 900 seconds. This will equal 16.09 repeating meters per second. I have 2 sig digs, so I just simplified to 16 meters per second. What's the direction? Doesn't have a direction because it's a scalar quantity. We only need to communicate magnitude. So now B is finding the average velocity. So make sure you write an arrow over top of your B now. So this is equal to D arrow total over T total. Now, my first direction was going what? East. Okay? So I went east first. I'm just going to write that in to myself here. So that was positive 5040 meters plus, what was my next direction? West. So my next direction is west. So I can't calculate west, so I'm going to replace the term west with a negative because it is a negative quantity. So I add a negative quantity, 16200 meters, all divided by 420 seconds plus 900 seconds. So my V average is equal to negative 8.45 repeating meters per second. So my question was phrased in terms of north, south, east, west. So I'm going to put my answer back into that. So my answer is a negative. I'm going to simplify it into my 2 sig. So I want to put 8.5 meters per second. So what direction am I going? West. Well, I don't, that's a good point. This number is negative, but it's like I took the negative and said, really that means west. So I don't put the negative there anymore. Do you guys, that's a really good clarification. So if you go into like west or a direction, you change that. It's like swapping it out. Okay, so there's a couple questions for you to do. I'll have the answers available for you to check them. If you finish, I will put some textbook questions on the board as well. And if you still have time, like you should check your review assignment and your graphing assignment if you need any help with those today. It's a good time to ask. Okay? So rest of the class is work time. So we have a good like half an hour. Oh, so I'm videotaping so that Robin can have our lectures. So do you all want to say hi to Robin?
Hi, Robin.
That's nice. Hi, Robin.